Imagine you're a chef, but instead of ingredients like flour, sugar, and butter, you're working with the very building blocks of the universe: elements, compounds, and mixtures. What if I told you that the secret to everything around you, from the air you breathe to the phone in your hand, comes down to understanding these three fundamental concepts? Stick with me, and by the end of this video, you'll be the master chef of chemistry, whipping up knowledge with the precision of a scientist. Elements are pure substances that can't be broken down into anything simpler by chemical means. Think of them as the fundamental ingredients in your chemistry kitchen. Most elements are actually mixtures of isotopes, which have the same atomic number but different mass numbers due to varying numbers of neutrons. You can see in here there are 3 different isotopes of oxygen: oxygen-16, oxygen-17, and oxygen-18. Here below, as you can see, they have the same number of protons and electrons since they have the same atomic number but different numbers of neutrons because they have different number of neutrons. If you are confused about how to find out the number of protons, neutrons, and electrons, don't worry. Check out our video on atoms. Subscribe to our channel to get notified about more videos on chemistry. Compounds are formed when 2 or more elements chemically combine. It contains more than one type of atom bonded together. Compounds are like recipes. When 2 or more elements chemically combine, they form something entirely new. You can see here the 2 elements. 2 atoms of hydrogen and 1 atom of oxygen chemically combine to form water, H2O, which is a compound. Both hydrogen and oxygen are gases, but when they chemically combine, they form liquid water. Did you also observe that compounds are made of 2 or more different elements? Common compounds are water, salt, silicon dioxide, hydrochloric acid, and nitrous oxide. Molecules consists of 2 or more atoms chemically bonded by covalent bonds. The atoms that make up a molecule can be from the same elements or different elements. Here is a molecule of water. The red atom is oxygen, and the 2 silver-colored atoms are hydrogen atoms. So in this water molecule, 1 oxygen atom is chemically bonded to 2 hydrogen atoms. Did you notice that the water molecule is made up of 2 different elements? This is a hydrogen molecule made up of 2 hydrogen atoms. Can you see that this molecule is made of the same element? The difference between a molecule and a compound is that a molecule can be made up of a same element or different elements, but a compound is made of 2 or more elements, which means that compounds are made of different elements. Can you see the oxygen molecule is made of the atoms of the same element? So it is a molecule, but at the same time, it is not a compound, since it is made of the same element. On the other hand, water, as we discussed before, is a molecule made out of the 2 different elements, oxygen and hydrogen. But it is also a compound as it is made of 2 or more elements. So all compounds are molecules, but not all molecules are compounds. In mixtures, various substances, elements, and/or compounds are mixed together and no chemical reaction occurs. Mixtures, on the other hand, are a bit like a salad. You toss various substances, whether they're elements, compounds, or both, together, but they don't chemically react with each other. Comparing mixtures and compounds. Let's break it down. Proportions. In mixtures, can be mixed together in any proportion. In compounds, the proportion of the elements is always the same. If you had the metal iron and some sulfur, you could mix them up in any proportion you wanted to. But in iron sulfide, FeS, a compound, the proportion of iron to sulfur is always exactly the same. Well, that is in a mixture, substances can be combined in any proportion, like adding a pinch of salt to your dish. But in compounds, the proportions are fixed, like the exact amount of ingredients needed to bake a cake. Properties. Each element in a mixture keeps its own properties. Compounds have different properties compared to the elements it is made from. For example, in a mixture of iron and sulfur, the iron is gray and the sulfur is yellow. The iron reacts with dilute acids, such as hydrochloric acid, to produce hydrogen. The sulfur doesn't react with the acid. However, the compound iron sulfide, FeS, reacts quite differently with acids to produce poisonous hydrogen sulfide gas, which smells of bad eggs. So, in mixtures, each component keeps its own properties, just like how each topping in a salad retains its flavor. Compounds, however, have entirely new properties, like how combining eggs, flour, and sugar creates something completely different, a cake. Ease of separation. Mixtures can be easily separated using physical means, for example, changing temperature. But compounds can only be separated by chemical reactions. For example, electrolysis. Mixtures are easy to separate using physical methods such as changing temperature, using a magnet, or dissolving part of the mixture. Think of it like picking out the tomatoes from your salad. But compounds require chemical reactions to break them apart. For example, a mixture of iron and sulfur is quite easy to separate into two elements using a magnet. The iron sticks to the magnet and the sulfur doesn't. The elements in a compound cannot be separated by physical means. To convert iron sulfide into separate samples of iron and sulfur requires chemical reactions. Melting and boiling points. Pure substances, like elements and pure compounds, have fixed melting and boiling points. For example, the melting point of water is 0 degrees Celsius and the boiling point is 100 degrees Celsius. Mixtures, on the other hand, tend to melt or boil over a range of temperatures. This is because of impurities, unwanted substances, in mixtures that can affect these points. For instance, dissolving 10 grams of common table salt sodium chloride in 1 liter of water lowers the melting point to about minus 0.6 degrees Celsius and raises the boiling point to about 100.2 degrees Celsius. So by measuring the melting point, you can determine if a substance is pure or not. So, whether it's the pure essence of an element, the unique properties of a compound, or the blend of a mixture, understanding these basics unlocks a whole new perspective on the world around you. If you found this lesson helpful and want to dive deeper into the wonders of science, make sure to hit that subscribe button and join the free Learn community. Keep learning, stay curious, and I'll see you in the next video.